Okay, today's video is about calculating probabilities using z-scores. So what is the point of finding z-scores? It's to use them in a normal distribution problem or a situation that is normally distributed to be able to predict their probabilities. Now, the reason why I say predict is that normal distribution is just a model that closely resembles all the natural occurring variables. It's not, no variable perfectly matches normal distribution, but it's close enough that it can give us a good estimate of what their probabilities are. And that's enough to make decisions around the size of populations and things like that. But what we have to always fall back on is that this is an estimate, it's not perfect. And particularly we're looking at calculating on the right side. So I'm breaking up the actual calculation part. It all follows the same process, but there's variations on the types of probabilities or the parts of the normal distribution that you are calculating. So depending on the different situation or the question that you get, you'll end up with this situation. So one of those is just simply looking at the right side. So what do I mean about on the right? So here's a normal distribution curve. I am talking about the area that goes from the mean. It goes to some point x on the scale. Now remember this normal distribution, it could be that x is the thickness of a tire. It could be the weight of an elephant. It could be the time it takes a student to get to school. Anything that's normally distributed. So this situation, we're talking about trying to work out the probability. If I know a time, what is the probability that that time and the mean, what is the size of that shaded in area? So here's an example of the type of question we're talking about. The weight of an avocado is normally distributed. The mean weight is 350 grams long, that shouldn't be there, and the standard deviation is 25 grams. What is the probability that a randomly selected avocado weight will be between 350 and 370.25 grams? So because this question is really wordy, it's difficult to know where to start. So the key thing is whatever questions we do for the next couple of lessons, there is a basic series of steps that you should always follow. The first of which is looking at drawing a picture of what you're trying to do. Draw a picture because it's hard to visualize what we're doing. And when I mean a picture, I just mean a normal distribution curve. So we're going to start off by looking at the numbers in terms of their real values, x. So remember x, the x variable is what we're talking is the weight of the avocados. So x is the weight of the avocados. What we're then going to do is convert it into z values, which are the standard normal values that we can use from the table that we looked at last lesson. So if we're using the real values, what we can see is that the mean is 350. Now we know where that goes in the middle. So the next part is trying to find the standard deviation, which in this case is 25. All right. The next part is it's telling you what the probability you need to work out. Now it's saying 350, which in this case is the mean. The other value that we wanted to find as borders the probability is 370.25. So if this is 350, 370.25 must be here somewhere. Now because it's just to give us a visual representation, the graph doesn't have to be perfect. what it should be is that we know 370 is bigger than 350, so it should be to the right hand side. And what we can do is we can shade that in to represent that's the probability that we're trying to work. So that's the probability x is greater than 350, but less than 375. So on the graph, what we're going to do, on the second graph, what we're going to do is we're going to try and work out what these values are in terms of x. Okay, in other words, calculate the z-score of these values. We can't put 370 into the table we've got. We can only put z-scores, so we need to convert everything. Now, the easy thing that we should remember is that 350 in z-scores, because it's the mean, is actually 0. The key is that 370 is above, but we don't know what that is as a z-score. So we don't know what 370.25 is as a z-score, but we do know that the standard deviation as a z-score is 1. So that's where the next calculating part comes in. And to work out what z is is we need to use this conversion value. All right. So the x value in this case is 370. Take away the mean divided by the standard deviation. So using these values, we should be able to work out that z is equal to 370.25 take away the mean, which is 350, divided by 25. Which is equal to 0.81. So step 3 is then to take that z value, which is 0.81, and look it up in the z-score table, which we've got there. So the key thing with, and I didn't talk about it last time we were looking at the z-score table, is that it's set up that to all measure the distance between the mean and whatever z-score you want to choose from. So this area here. Now the reason why it does that, and the reason why there's no negative values, is that because of the symmetry of normal distribution, the value is exactly the same. In other words, the value we get for 0.81 will be the same as if it was minus 0.81. So obviously this part's just showing you that we're measuring from there. There are some textbooks and things like that that use normal distribution tables, and what they use instead, rather than going from the mean, is it's all the probability of everything below that. So you just got to be careful, whatever table you're using, that it's the one that measures from the mean, and that's consistent with the one that will be in the exam at the end of the year. So here's our table down there. What we need to do is find 0.81. So the first thing is to look for the first decimal point, and then the second decimal point, and then the third decimal point. So in this case, the first decimal point is a decimal value is 8 or 0.8. So we're looking at this line here. The next part is it's 0.81. So we're looking here, meaning that this is our value here. So the probability that x is greater than 350 but less than 370.25 is equal to 0.2910. And the reason why we know that is because the z value is 0.8, and that's because the standard deviation is the proportion is 0.81 of the standard deviation from our real world example. So there's one more step, but I'm going to tidy up all these ink values and keep the ones that are most important. So there is one last step that we have to look at, and it's usually the one that's forgotten the most. But what you need to do is make sure you write the probability in context. So we have a context about the avocado weight, so we need to make sure our answer is given that way. So we can say the probability that an avocado weighs 370.25 but more than 350 is 0.2910. So that bit's really important because you haven't been asked a question about finding x or any of those things. What you have been asked is a real world question about avocados. The other thing I forgot to mention as we were going through there, I've done two diagrams to show you the link between x, the real world values, and z, the standard normal values. In reality, it's only a diagram of x that we need because, as you can see, they look exactly the same. So once we've got x and we see that, then we can use the calculation to work out the z value. So you only really need one diagram in your answer. So we'll have a look at another example, and this time rather than explaining lots of different bits, I'll just go through and explain what the answer is. So the thickness of slate tiles is normally distributed with the mean thickness of 4.6 and the standard deviation is 0.6 millimeters. What is the probability that a randomly selected slate will have a thickness between 4.6 millimeters and 5.1? So the first step is exactly the same as before, but we need to draw a picture of what's going on. So there we've got the one diagram. So just going to be interested in x at the moment. So first thing we do is put the mean in, which we can find over here, which is 4. The second thing we can put in is standard deviation. And in that case, it's 0.6. The next part is that the area we're trying to work out is 4.6. That happens to be the mean. And the second area is 5.1. Now 5.1 is bigger than 4.6, so we put it on the right. So we're trying to work out this area. So now that I'm put in, what I need to work out this probability, I need to think about the z value. Show the difference between the x and the z. I'm going to change the color to black. So first of all, we know that the mean is 0. And we know that the standard deviation is equal to 1. Now 5.1 is the one that we don't know. So that's the situation we've got. We've got to work out what 5.1 is in z values. And to do that, we have to calculate the z score using our formula. So we can have a go at substituting our values into the formula. If you want to have a go at doing that yourself, and then you can pause the video, do it, and then come back, and then I would have written the answer in. So pause the video now. Here you go, I've substituted in the values, and hopefully that's what you put in. We calculate the answer. What we get is 0.833. And obviously the 3's recurring, but because we've only got because we've only got a chart that does 3 decimal places, we should round to 3 decimal places. So looking at our table, as we look up our table in our calculation using step 3, is that we can look at 0.8 as our first decimal place. Second decimal place is a 3. So that means we are looking at this number, but because it's 3 decimal places, we need to use this column on the back. Looking at the 3 decimal places, we move along to 3, and then using the same line, making sure we don't make a mistake is we have to add 8 on there at the end. So our probability is equal to 0.2967 plus 0.0008. So, which means our probability is 0.2975. That means the area in our diagram here is 0.2975. So the last thing we need to do is write our answer in context. So it means the probability that slate is between 4.6 and 5.1 millimeters in thickness is 0.2975. So that's basically the whole task. You can see the steps are exactly the same. Key thing, draw a picture, calculate the z-score, look it up in the probability table, and then write your answer in context. So there's some questions and a worksheet which you should complete. More practice, it's more about practicing the procedure, because if you nail this now and remember all the steps, it will make the next few lessons pretty straightforward.